Hello together. This video is a short introduction of the new API Ethernet IP web server. The video fits for the firmware 1.3.1. This is the newest firmware for the API Ethernet IP system. And if you are going here, for example, to quick search and to the support portal, then you find this firmware here at software in the support portal. And you see it here. There is the firmware available. And this is really pretty new. You see here 13th of April 2021. And the video what I make right now is exactly for this firmware. To use the web server, first of all, I have to know the IP address. And with the Festo Field Device tool, I can scan the network and see the IP address. And you see here the IP address is 192.168.0.5. This IP address I have assigned already via the DHCP BootTP application and changed it to fixed. If you want to know how this is working, look in the previous video or have a closer look in the manual. With the IP address, I'm just opening here the web server by typing in the IP address 192.168.0.5, and this here is the starting screen. And what you are recognizing here is you see here the topology of your API system with Ethernet IP. And here is our first module, which is the Ethernet IP node. And on the left side, we have here a VEAM, which is a VTU-G Wolf terminal, and then an MPAL Wolf terminal. And here, if we are going to the right side, we are starting with the IO-Link master, the 80 digital input module, 4DI, 4DO, and here is the analog input module. You see here the module code, the firmware version, the serial number, and the actual product key for the module. First thing what you are recognizing here is the identify button. With this, you can check if the module is available by the API system. If I activate this and go here to my camera, then you recognize here that the module is here available by these flashing lights. I can, with this behavior, switch on all the modules, and then you are seeing here that the modules are all available. Here on the right side, you will recognize now everything is flashing, and I can now switch it off here again. And this is for the first check, very easy. You see here this button where you can change from information to the process data. Here you see now the process data of our system here, and you see here 0, 0, 0, 0, 0. And if I go here, for example, to my running logics project, I can here switch on, for example, the coils. You see the coils are on now here. I can also switch on the next coils here. They are also on. And if I'm going now back to the web server, I'm recognizing this here directly. We have also offered here now the supply voltages of the system. You see here the sensor supply for the API communication, here the load supply for the digital outputs and coils. This is the current value, what is here used. You can use this functionality, for example, to may identify some power fluctuations of your power supply, but this would be one use case, or just observe what is at the moment available on the system. Here also the cable information, where you are just checking how long are the cables between the single modules. This here is also available here in this tab. The next thing is now here the Ethernet IP tab, the assembly view. You see here the assembly view, and you see here all the possibilities of the API Ethernet IP module. You see that we have here in the module a lot of assemblies which you can use in your Logix project, and depending on your application you find here directly the assembly number plus what is your current system allocating. For example, here you see my actual system has here assembly 100, which is 46 bytes. This view I can use to define here in my Logix project exactly my connections, which are the assembly views with the Festo EDS, for example, and here the exact size that I have no errors during the commissioning. The assembly view also offers me the possibility to find out where are the API module and the digital output, for example, are located. You see here the offset, and you see here this information. And if we scroll down and go, for example, to our 4DI DO, then I'm recognizing now here the input would be located at 296. The same is matching for the exact output size, and here you see that the 4DI DO first output is located at 312. Depending on the assembly connection what you are using in your project, you can use this view to find out the location of your tags in Logix. For example, 3112 would mean with a SINT format divided by 8, location at tag 39. Going back now here to my view, to my controller tags, you see here the output area, and if I scroll down, then 39 is here, and here I can now switch on the coils of my 4DO, 4DO. You see this also now here. I switched on the coils, and of course I can also switch off the coils again. Now the coils are off. This is a helpful possibility with the assembly view to find out the bit offset of the system. Of course, with the web server, you can also download directly the EDS file. The EDS file is also available, of course, in the support portal. If you go here again to the support portal, then you see here at software, device description files, the EDS file, but it is in the web server also directly downloadable. Here, the next thing would be the L5X project. With this, you are generating a file which you can use in Logix. How this works in detail, please have a look on our video where I explain this. It has a lot of advantages. If someone is not using our Ethernet IP node in Ethernet IP mode, then we have here the Modbus TCP feature. Means we are using another mode with the node, and the PLC is a Modbus TCP master. Here in the web server, we are showing the holding registers. We can copy all the registers to a file and make our tag assignment if we want. We see here also the input registers, the same possibility, copy everything. And you see here also the addresses where this information are located. Here the supported function codes by our node, if you are using the Modbus TCP mode, also available for you that you are have a short overview what can our node supports. Then we have here the configuration. You can now here define a new password or you can also change the password. Per default, the password is admin and the product key. The product key is on the label of the node, or you are using, for example, here again, our test field device tool, and then you are copying the product key, which is here located, Control C, to this, and then here the possibility to change username, password, etc. If you want to have a secure system, of course, please change the password for your needs and save the password somewhere that you don't forget it after several of years. If whenever you are forgetting the password can be happen, then have a closer look here inside the operating instruction. If you check the technical documentation, then you will recognize very fast that the hmm, rotary switch can be your solution if you are forgetting the password, because here in the rotary switch we have the possibility to reset everything if we are using the value 900. This is for you just important to know if you have forgotten the password. Furthermore, you can use here the firmware option where you download the firmware directly to the node for a firmware upgrade, or you can also use this here to upgrade module firmwares. This is directly integrated in the web server for upgrading, downgrading firmware of the system. S&P is also here available for the IT if they have a use case for our node. And then we have here the stored parameter feature. This is something where you are saving the module parameters inside the node. This I am explaining in a later on video, but it is already integrated and helps you a lot if you have, for example, not a Rockwell PLC where the L5X export is not working and you need to change the parameters and store it in the node. In the system, you have here the diagnosis information where you're seeing all the actual diagnosis, also some errors which I have done already. You have the information about the node itself. You see here in my case, the HCP is already disabled because I have used it at the beginning. You see the firmware, the bootloader. And the last thing what I want to show you is if you are going here to the AP tab and you are clicking, for example, directly on the module, then you can change the parameters via the web server during operation. With this, you can make some pre-testing before the machine is running and you can check your parameters. Very important to know is if you are changing here the parameters, you have to be logged in. I was logging in before with admin and product key. That's the reason why this change was working. And this is the first thing what you have to know. You have to be logged in. The second thing is this is just for testing purpose. As soon as you power off on the system, you will recognize that the parameters are gone. You see here, it's again seals this. This you have to know. You can change the parameters, of course. This change is active during operation. After power off on, we are starting again with the parameters which the PSC is may sending, or with the stored parameters. The rule at Festo is, for example, PLC has the highest priority to change the parameters by the configuration text if you are using the L5X export. Then the second one is the stored parameters functionality. If you're using this, everything is stored inside the node. And the last one is here. We are starting up with default parameters, and this you cannot change. This is the direction, how the whole parameter stuff is working at the API node. PLC has the highest priority if you are using their parameters. Then secondly is the stored parameters, and third is the default parameters. And any change in the web server during operation has an effect, but it is not remanent, because after power off on, we are starting again this direction 1, 2, 3, and everything what we have done is overwritten. So this was now a short introduction about the web server. I hope you have enjoyed it, and I wish you a nice day. Thanks for your attention.